Hi, this is Miss Milton. This video is to help you learn how to add and subtract polynomials. I hope you find it helpful. We're going to start with just looking at some pictures to get an idea of how to add and subtract different things together. If you looked at this first problem, you'd see check marks, hearts, and stars. I'm going to pretend it's a big addition problem. And if we're going to add things together or look at this, I think with confidence I would say, well, to clean this up a little bit, I would say we have 4 hearts. And then to clean it up a little bit more, I would combine like terms and say, well, I have 3 stars. And then to finish it up, I would say I also have 1 check. So if I was going to add this together, that's what I would do. 4 stars plus 3 hearts plus 1 check. I can't really combine it any more than that. Let's look at this next grouping. I've got a Z plus an X, a Y, an X, a Y, and an X. So to clean this up or simplify it a little bit, I try to combine some like terms, and instead of saying I have X plus X plus X plus X, I would say I have 4 X's. And then instead of saying I have Y plus Y, I would say, well, I also have 2 Y's. And then I would finish by saying I have 1 Z, or just Z. If you wanted to put the 1 in there, you certainly can. So that's the idea of combining like terms. Let's look at another example. There's a lot going on here. But if I just take some time and I don't get stressed out, I could see I have one big polynomial here, an addition sign, and another big polynomial here. Let's try to clean this up. Now I look at this guy on the left and I see I have 1, 2, 3, 4, 5 p squares, or p's to the 2nd power. So I'm going to clean it up and write my first polynomial like that. I have my big addition sign, and over here I've got, it looks like 2 p squareds and 3 p cubes, or p to the 3rds. So now, I want to kind of combine like terms anymore. I actually want to add these together. So what I think I'm going to do is rewrite this without the parentheses. 5p squared minus 3 plus 2p squared cubed. All right, so I'm looking to combine some like terms here, and I see I've got a 2p squared and a 5p squared. My constant of -3, I don't have any other constants, and then this 3 has a p cubed behind it. No other numbers or no other coefficients have a p cubed behind it, so that one will stay on its own. So now to rewrite this, the 3p cubed is going to stay on its own. The p squareds I'll combine together. 5p squared plus 2p squared is a plus 7p squared. And then the constant of a -3 stays by itself. Please notice that this is written in standard form. The term with the highest exponent was listed first. The term with the next highest exponent was listed second. And you save your constant for last. Let's try another. So this one looks a lot like what your homework is going to look like. I see a binomial plus a binomial. I recognize that it's the adding problem because of the addition sign right there. When it's an addition problem, I'm going to rewrite it without the parentheses. 4 plus 2n cubed plus 5n cubed plus 2. Do I have any like terms? I see this positive 2n cubed. The positive 2 has an n cubed and the positive 5 has an n cubed. I also see that I have a constant of 4 and a constant of 2. So if I combine my n cubes to 7n cubed, and then 4 plus 2 is 6. Please notice here, I added the coefficients, the 2 and the 5, to get the 7, But the exponent of 3, I did not add to become 6. It just stayed at 3. Because remember, this is saying I have 2 n3s, and this one is saying I have 2 n3s, and this one is saying I have 5 n cubes. Altogether, I have 7 n cubes. This is written in standard form because the thing with the exponent, or the term with the exponent that's the highest, is listed first. The constant is listed second. All right, now this represents a different kind of problem. If you notice, I've got a subtraction problem going on right here. If I wrote this out in words, I would say I have, let's try with a pen. I would say I have 4 hearts, and I'm taking away 4 stars, and I'm also taking away 3 hearts. So this negative right here, it matches with the stars and it matches with the hearts. That negative goes for everything inside these parentheses. So it's like we're using the distributive property here and thinking of this negative goes with the stars and with the hearts. So again, I have 4 hearts. That came from here. I'm taking away 4 stars, and I'm also taking away 3 hearts. So how can I combine some like terms here? Well, it looks like I have 4 hearts, and I'm taking away 3 hearts. So that gives me 1 heart left, and then I'm taking away 4 stars. I can't combine that with anything because there's no other groups of stars available, so that's as simplified as it gets. So let's follow the same process here. I know that this is a subtraction problem because there's the subtraction sign between the two polynomials. So I'm going to remember I'm not only subtracting a 5n cubed, I'm also subtracting a 4n. So when we go about this problem, it's very similar to the addition problem, where I'm going to rewrite the first polynomial where I take away the parentheses. But then for the second one, I have to apply this negative. It's almost like there's a -1 there, and I'm going to do the distributive property. So -1 times 5n cubed is a -5n cubed, and -1 times a 4n is a -4n. So really what happened here is the positive 5n cubed became a -5n cubed, and the positive 4n became a -4n. So remember, you have to distribute that negative, so you take the opposite for the terms in the second polynomial. Now you're ready to combine like terms. I've got a -3n cubed and a -5n cubed become -8n cubed. And I've got a positive 4n and a -4n, which becomes a 0n. So my final answer here will be a -8n cubed. Let's try one more subtraction problem. This will be the last one for the day. Please stay with me. I know that this is subtraction because in between my two polynomials, there's a subtraction sign. It looks like I have a trinomial here with 3 terms, subtracted by another trinomial with 3 terms. Okay, so for subtraction, I remember that that negative has to distribute with everything in the second polynomial. So I'm going to get things going by rewriting my first polynomial without the parentheses. Now it's time to distribute. I'm going to rewrite the second polynomial, but I'm going to multiply each term by this -1. So really, it's just going to be the opposite of what I had. So the -3k to the 4th becomes a positive 3k to the 4th. A -14k squared, 14k squared. And the -8 becomes a positive 8. Now I'm ready to look for my like terms. I have a -4k squared and a positive, nope, those are not like terms. Yikes. The positive 4k squared is a like term with a positive 14k squared. And it's also a like term with a positive 3k squared. That one has 3. I have a constant of a positive 14 and a constant of a positive 8, so I'll want to combine those. And then this 3k to the fourth, there's nothing else that has a k to the fourth, so that one's going to stay by itself. So when I combine my like terms, a negative 4 plus 3 plus 14, well, negative 4 plus 3 is negative 1. Negative 1 plus 14, I have a 13k squared. If I add my constants of 14 plus 8, that's a plus 22. And then I have this positive 3k to the fourth at the end. I'm going to rewrite this so it's in standard form. So the term with the biggest exponent is listed first. The constant is listed last. So this would be my final answer right here. All right. That's it for today's lesson. You're adding and subtracting polynomials. The biggest thing to remember is when you are doing the subtraction, there's a subtraction sign between the two. You have to distribute to that negative, so it'd be a negative x minus 3. You would keep the first one exactly the same. Once you do that, you're ready to combine like terms and finish. All right, you have a short assignment to work on. You can either print it out or write it on your own paper, and please upload it to Schoology. Join conferences if you need any help. Best of luck.